show that the vector field f given by this is conservative, then find a potential function f. That is, find f is a function of two variables such that gradient of f is just this function. So note that the domain of this vector field f is whole R2, the plane, an open and simply connected region. Okay. So here this f, we got two components. We can say first is p is a function of x and y, and q. Okay, so we can write here p is a function of x, y is just sine y plus y ex, and q is ex plus x cosine y. Let's find parcel of p with respect to y. With respect to y, derivative of sine y is cosine y, plus ex is constant with respect to y, and derivative of y is 1, so just ex. Partial derivative of q with respect to x is now ex is just ex. X derivative of x is 1 times cosine y. They were backward but both plus, so they are same. That means this vector field is a conservative vector field. That means we can find a function f, is a scalar function, whose gradient, when we find gradient of this, which is fx and fy, and this is just f given here in the question. Okay, so let's follow the following procedure. Since this is a conservative field given here, so the first part here will be partial of little f with respect to x, and second part will be partial with respect to y. Okay, now you can forget about what we just did. These partials are just to check if the vector field is conservative or not. So once we check, then we just forget about this. Okay, since this is conservative, then there exists a function fxy, that's what we are trying to find, such that its partial with respect to x is first. So partial with respect to x is sine y plus y ex, and let's say this is equation 1, and partial with respect to y is this ex plus x cosine y. Okay, now integrate first with respect to x, or we can integrate second with respect to y, same thing. Integrate equation 1 with respect to x. Okay, then when we integrate with respect to x, this is pretty much derivative with respect to x, so just function f survives. This is a function of xy, in fact, is equal to integrate this. So antiderivative of sine y plus y ex with respect to x. First is just like constant. With respect to x, it's a constant, like say 5, and antiderivative of 5 is just 5x. So this is sine y x. I'll write that here. Plus, when we integrate second, y is constant, y, and antiderivative of ex is just ex. Okay, and plus c, plus constant, but since we have partial derivative, that constant could be a function of y. So we just write hy. Yeah, this function could be a pure constant like 5, 7, 10, -5, etc. Or it could be a function of y. Since we are integrating with respect to x, function of y is also a constant. 3, where h is a constant function. Where h, not a constant function, h is a constant. H is constant in our case. It could be a function of y as well. Now, I mean, this is the function. This is the function we are looking for, provided we know h. Okay, so as soon as we find the value of h, we are done. Now, to determine the value of h, let's do the following. Look, equation 2 is parcel of f with respect to y. So we have f here. Let's find parcel of f with respect to y. Then we can compare with 2. So differentiate equation 3 with respect to y. F y equals, with respect to y, x is a constant, derivative of sine y is cosine y, plus ex is constant, derivative of y is 1. Now find the derivative. This is pure function of y, or constant, so we write regular derivative h prime y. Okay, because this is a single variable function, so h prime y. Equation 4. Now we compare 2 with 4, and hopefully we get the value of h from here. So if we compare 2 and 4, because we have fy in the left hand side, right hand side, look at here, ex, they are same. X cosine y, they are same. That means h prime y should be, there is nothing means 0. I mean, we can always write plus 0. So h prime y should be 0. Compare equation 2 and 4. There is nothing equals h prime y, means h prime y is 0. And if we integrate both sides, that means h is just a constant, because derivative of constant is 0. Okay, so it's a constant, and we may take that constant be 0 as well, because we are just finding a potential function. So our potential function is here, and that was the case. With h, we just found a constant. We can write a constant, or we may take c equals 0. Okay, we may take c equals 0. Thus, a potential function is given by 3. F as a function of x, y is x sine y plus y ex plus h is 0. We don't have to write that. Final.